Hello guys, welcome to Makaut Smashers, and also welcome to this embarking journey into the fascinating world of cryptography in computer science. Cryptography might sound complex, but it's essentially the art of keeping the information secure and confidential. Imagine you are sending a secret message to a friend. In old days, you might use a simple code like replacing each letter with one following it in the alphabet. Okay, like Caesar cipher. This way, even if someone intercepts the message, they won't understand it without the key knowing the shift. Okay, so fast forward to today's digital world where everything is ones and zeros. Cryptography plays a crucial role in securing our online interactions. It ensures the confidentiality, integrity. Okay, and think about the online banking or sending the sensitive documents. Cryptography scrambles the data, making it unrepeatable to anyone without the secret key. It's like having a personal vault for your digital information. But cryptography is more than just hiding messages. It also helps with authentication, non-repudiation. Okay, so as we progress through this video, we will delve deeper into these concepts and explore the different types of cryptography used in computer science. We will see how these techniques safeguard our online activities and build the foundation of trust in digital world. So are you ready to unlock the secrets of cryptography? So let's begin. Okay, so now it is time to unlock the fundamental ideas that make it work. So we will break down the key concept that form the foundation of secure communication in the digital world. At first, confidentiality. Imagine whispering a secret to a friend. Confidentiality in cryptography ensures only the authorized parties can access the information. It's like having a padlock on your data, accessible only with the right key. So encryption. This is the process of scrambling the plain text, means the readable information, into the cipher text, unreadable form, using a cryptographic algorithm and a key. It's like transforming your secret message into gibberish before sending it. Decryption. The authorized recipient use a decryption key to unlock the cipher text and retrieve the original message. It's like using the correct key to open the padlock and understand the secret message. Okay, so number 2, integrity. Ever received a garbled email or a corrupted file? Data integrity ensures the information remains unaltered during transmission or storage. It's like having a tamper-proof seal on your message, guaranteeing it has not been tampered with. Like hash function. These are the special algorithms that take any input data and generate a unique fixed size output called a hash value, like a digital fingerprint. Any change to the data will result a completely different hash value, allowing the detection of tampering. Digital signature. These are like electronic signatures that use the cryptography to verify the authenticity and integrity of a message. The sender digitally signs the message using their private key, and receiver can verify the signature and the sender's identity using the sender's public key. Number 3, authentication. In today's online world, verifying who you are communicating with this is crucial. Authentication ensures you are actually talking to the intended recipient or not an imposter. It's like checking someone's ID before sharing sensitive information. So cryptography uses various techniques for authentication such as challenge response system, digital certificates. Okay, challenge response system means the sender sends a challenge like a random number and the receiver responds with a transformation of the challenge using a shared secret key. This confirms the receiver's identity by proving they possess the secret key. The digital certificates. They are electronic documents that verify the identity of a person or entity online. They are issued by trusted authorities and contain a public key that can be used for secure communication. Number 4, non-repudiation. Imagine sending a mail and the recipient later claiming they never received it. So non-repetition ensures the sender cannot deny sending a message later. It provides a digital proof that a message originated from a specific sender. Digital signatures, as mentioned earlier, play a vital role in non-repudiation. By signing a message with their private key, the sender creates a undeniable link to themselves as the originator of the message. So these are the core concepts from the bedrock of cryptography. By understanding them, you will gain a deeper appreciation for how cryptography safeguards our digital interactions and builds the trust in the online world. So in the next part of the video, we will explore the two main types of cryptography that leverage these concepts in different ways. Okay, so now we can conclude that we are familiar with the core concept of cryptography. So let's delve into the fundamental approaches used to achieve the secure communication. At first, the symmetric key cryptography, shared secret key. Imagine two best friends sharing a secret code to exchange message. Symmetric key cryptography works similarly. Both sender and receiver use a single shared secret key for both encryption and decryption. So the efficient and faster for encryption and decryption due to using the same key, though this is some advantages like well suited for the bulk encryption of large data sets. Okay, and also some disadvantages like that key distribution is a major challenge. Both parties need the same key securely, which can be difficult to arrange, especially for large groups. If one party's key is compromised, all communication secured with that key becomes vulnerable. Okay, so common symmetric key algorithms like Advanced Encryption Standard (AES), the current industry standard for symmetric encryption, known for its strength and efficiency. Data Encryption Standard (DES), an older algorithm still used in some legacy systems. Okay, so number 2, asymmetric key cryptography or public key cryptography. Imagine having a public mailbox and a personal logbox. Asymmetric cryptography utilizes a key pair, public key and private key. Public key means freely available for anyone to use for encryption. The private key kept secret by the owner and used for decryption. So some advantages like eliminates the need for security or secure key distribution. Anyone can encrypt messages with public key, but only one holder of the private key can decrypt them. Provides a mechanism for digital signatures using the private key to sign the message and the public key for verification. Okay. So some common asymmetric key algorithms like Rivest-Shamir Edelman or RSA algorithm, a widely used algorithm for secure communication and digital signatures. ECC, elliptic curve cryptography. Okay, so offers smaller key sizes for the same level of security as RSA, making it efficient for resource constrained devices. So in the real world, these two types of cryptography are often used together for optimal security. For instance, secure communication protocols like HTTPS often use public key cryptography, symmetric key cryptography. Okay, so by understanding these two types of cryptography, you will gain the vulnerable insights into the how information is secured and in various applications like online banking, secure messaging and digital certificates. So in the next part of this video, we can explore some specific applications of cryptography in computer science. So now this is the time to discuss about the application of cryptography. Okay, so cryptography forms the backbone of secure communication and data protection in vast realm of computer science. So first, secure communication. HTTPS, the foundation of secure browsing like HTTPS, use a combination of symmetric and asymmetric cryptography to encrypt the communication between your web browser and websites. This ensures your data like login credentials or credit card information remain confidential during the online transaction. VPNs or virtual private network. VPNs encrypt your internet traffic, creating a secure tunnel between your device and a remote server. This is particularly important when you are using public Wi-Fi network. Email encryption. Secure email service use cryptography to encrypt email messages and attachment, safeguarding sensitive information from prying eyes. Okay, data protection, like disk encryption, protects your data at rest of your computer's hard drive. Even if someone gains physical access to your device, the encrypted data will be inaccessible without the decryption key. File encryption allows you to encrypt the individual files or folders for added security. This is useful for protecting confidential documents or personal data. Authentication and authorization. Password hashing. Passwords are never stored directly on your system. Instead, cryptography is used to create a one-way hash of your password. When you log in, the system generates a hash of your entered password and compares it to the stored hash. If they match, the authentication is successful. Digital certificates. These electronic documents issued by trusted authorities verify the identity of websites or individuals online. They use cryptography to establish a secure connections and ensures you are interacting with the intent party. Blockchain technology. So, cryptography plays a vital role in securing the blockchain networks. The foundation of cryptography is like Bitcoin. It ensures the integrity of transactions, data, and prevents the unauthorized modification of blockchain ledger. So, other applications like secure message apps, software updates with digital signature for authenticity, secure storage for sensitive data in cloud environment. Okay, so cryptography's application extend far beyond this list as technology evolves. So do its application constantly adapting to meet the new security challenges in the digital landscape. So in the final part of the video, we can briefly touch upon the ongoing challenges in cryptography and explore what the future holds for this ever-evolving field. So at last, alright everyone, that's a wrap up on our journey into the world of cryptography of computer science. Hopefully by now you have a better understanding of how cryptography safeguards our digital lives. From securing online transactions to protecting our privacy, cryptography plays a critical role in today's interconnected world. Okay, so hopefully remember, cryptography is a vast and fascinating field. If you are interested in learning more, there are plenty of resources available in online and in libraries. Thanks for joining me on this exploration. If you enjoyed this video, be sure to leave a like and subscribe for more tech adventures. Don't forget to hit the notification bell so you never miss a future videos. And always stay curious and stay secure in the digital world.